All right, let's jump right into this explainer where we're going to completely demystify the absolute most mysterious extreme objects in the known universe. We are talking about literal cosmic titans. Things that can bend the path of light, practically slow down time itself, and possess enough gravitational strength to just tear apart entire solar systems. And as you'll see by the end of our time together, not all of these dark giants are created equal. To really wrap your head around this, put yourself in the middle of a thought experiment for a second. Imagine an enormous amount of matter, entire planets or even whole stars, and just squeeze all of that down into an incredibly tiny space. When you compress that much mass into such a microscopic volume, the normal rules of reality just snap. Gravity becomes so unimaginably powerful that literally nothing can escape its grip. So what exactly happens when gravity breaks the universe? Well, here's our roadmap for exploring these titans today. 1. Anatomy of the abyss. 2. Sizing up the heavyweights. 3. Ancient and microscopic. 4. Bizarre spins in tunnels. And finally, 5. The ultimate mystery. Let's get into it. Section 1. Anatomy of the abyss. The basics of a black hole. Okay, to understand the foundational anatomy of these objects, we really have to look right at the center. The exact point where gravity becomes so overwhelmingly powerful that absolutely nothing, not even light itself, can escape the darkness. This point is called the singularity. Here, the sheer amount of density completely shatters the limits of human comprehension. To put it simply, imagine taking the weight of millions of Earths and crushing them all down into a single, infinitely small dot. Because not even light can bounce off of this infinitely dense point and reach our eyes, black holes appear completely, terrifyingly dark. Now, wrapping directly around that singularity is the event horizon. You can think of the event horizon as the ultimate boundary line in space. If you're standing outside of it, hey, you might still have a chance to escape. But the exact millisecond you cross that line, yeah, you've reached the absolute point of no return. A really great way to visualize this is to imagine the event horizon like a massive cosmic waterfall. Picture yourself in a boat on a river, just paddling upstream as fast as you possibly can. If the current of the river, which in this case represents gravity, is pulling you over the edge faster than your boat can paddle, well, you're going over the falls. At the event horizon, the current of gravity is pulling inward faster than the speed of light itself, and since nothing in the universe is faster than light, nothing can paddle upstream against this cosmic waterfall. Section 2. Sizing up the heavyweights, from stellar to supermassive. Let's see how this all builds as we scale things up in size, starting with the most common ones. These are literally born from the ashes of dying stars. A stellar black hole is created through just an incredibly violent life cycle. First, a massive star simply runs out of the nuclear fuel it needs to keep burning. Without that outward energy pushing against its own massive weight, the star collapses and explodes in a totally spectacular supernova. Finally, the remaining dead core of that star collapses entirely under its own gravity, just crushing inward until a stellar black hole is born. Now, what's really wild is that these stellar black holes contain anywhere from 5 to 100 times the mass of our entire sun. But because of that intense core collapse we just talked about, all of that mass is packed into a space just a few kilometers wide. It's the cosmic equivalent of taking the entire mass of Mount Everest, the whole mountain, and squeezing it down to the size of a tiny glass marble. And the jump in scale is just staggering from here. We go from those stellar masses up to intermediate black holes, which astronomers actually recently discovered hiding inside dense star clusters. Those contain thousands of solar masses. But then we skyrocket up to the true kings of the cosmos, the supermassive monsters. We're talking millions or even billions of times the mass of our sun. At the center of almost every single galaxy lies one of these supermassive black holes. For our own Milky Way, it's a monster called Sagittarius A star. These objects are so unfathomably large that some of them could swallow our entire solar system whole. Yet, what's fascinating is that despite their terrifying size, entire galaxies, including our own, just manage to orbit peacefully around them, much like planets orbiting a star. Section 3. Ancient and microscopic. Extremes of time and size. So, unlike the normal black holes we just discussed, which are born from dying stars, some scientists believe there's a category called primordial black holes. These would be older than stars themselves. They're thought to have formed mere moments after the Big Bang, born not from collapsing stars but from extreme density fluctuations in the incredibly chaotic early universe. Some theories even suggest that these ancient primordial black holes could be the key to explaining the whole mystery of dark matter. On the complete opposite end of the spectrum from the supermassive giants are theoretical micro black holes. These are hypothesized to be smaller than a single atom, yet they'd be packed with absolutely incredible amounts of energy in that microscopic space. Now, some scientists once worried that particle accelerators could accidentally create them right here on Earth. But the amazing thing is, even if they did form, physics tells us they'd evaporate almost instantly through something called Hawking radiation. They'd basically disappear in a flash of energy, kind of like a drop of water sizzling away on a scorching hot frying pan, long before they could do any harm.
Section 4. Bizarre spins and tunnels, breaking space and time.
So it turns out not all black holes just sit there perfectly still. Many of them, known as Kerr black holes, rotate at unbelievable, totally extraordinary speeds. Think of a spoon stirring a really thick jar of honey. As the spoon spins, it drags the honey along with it, right? Kerr black holes do this to the actual fabric of reality. Their rotation physically twists space-time itself, creating bizarre effects that were precisely predicted by Albert Einstein's theory of relativity. Near these spinning black holes, time actually moves differently than it does for the rest of us. Now, if we take that physics and entirely flip it on its head for a second, theory suggests the exact opposite of a black hole could exist, a white hole. While a black hole intensely pulls matter inward to a point where nothing can escape, a white hole intensely pushes matter outward to the point where absolutely nothing can ever enter it.
And this leads us to an incredibly exciting speculation. Scientists think that black holes and white holes might actually be connected to each other by wormholes. You can think of a wormhole like folding a piece of paper in half and punching a pencil straight through it to connect two distant points. They'd be literal tunnels through space and time, potentially allowing instant cosmic shortcuts across vast distances. Now, to be totally clear, we don't have direct evidence that wormholes exist yet, but the math says they are absolutely possible.
Section 5. The ultimate mystery, challenging everything we know. So, why does understanding these abyssal giants actually matter to our core understanding of reality? Well, because black holes challenge literally everything we know about physics. Inside the event horizon, our understanding of space, time, and gravity completely breaks down. The normal rules just no longer apply. Because of this, they hold the ultimate keys to unlocking the deepest roles of quantum mechanics, solving the true nature of dark matter, and perhaps even revealing the origin of the universe itself. Every single time we observe them, they force us to rewrite the textbooks. The more scientists study black holes, the stranger and honestly more fascinating they become. Somewhere out there in the vastness of space, countless black holes are just waiting to be discovered. If these cosmic titans truly hold the secrets to the very origin of our universe, what else is waiting in the darkness to be discovered?